All right, so this is neat, right? Sum and difference identities. This is neat, but none of these are things that I feel like you have to memorize. They don't come up enough that it's important for you to memorize. If they're nice to know, we're going to manipulate it a little bit, but I don't expect you to have any of these memorized. It's just another set of identities. All right. So then we're going to kind of take a break from the verifying part of this and just literally using identities as formulas. That's kind of what's happening with these sum and difference ones. All right. Okay. So let's just write them all out. We have cosine, sine, and tangent are the three that we're looking at. Oops, that's not helpful. Cosine of, and I'm going to write these together. A plus or minus B is equal to cosine A cosine B minus plus sine A sine B. All right, so for this first one, I'm going to write this out so you can see the difference between these and where it's actually kind of coming from. So you actually have two of them here. My formula is cosine of A plus B would be cosine A cosine B minus sine A sine B. Do you see that? The identity is the same for both except the sign. The plus on top goes with this minus on top. Plus goes with minus, which means this minus on the bottom goes with this plus. Do you see that? So your sum and difference identities literally are the same for everything. The output is the same. It's just the signs vary. Okay, so here is sine. Sine of A plus or minus B is going to equal, sine A cosine A. They're different. I said B. I think I said A and I meant B. Sine A cosine B. They're different that they have there, but the signs match up, and then it is cosine A sine B. Now, whenever I memorize these the first time, like for me personally, I always did sine, cosine, and I just knew that my first one was A, then it went to the second one, then sine did the second one, then the first one, however you want to do it. So it's sine A cosine B. Then you swap the angle measurement. Cosine goes with A and sine goes with B. The plus goes with the plus. The minus goes with the minus. All right? Let's look at tangent. So I have tangent A plus. So the plus goes with the plus for these. On the top anyway, tangent B, and then this one is a rational expression, and then this will be 1 minus plus tangent AB. So the numerator for tangent is plus, the same thing as the addition, but the denominator is opposite in sign. So minus to minus, and then the denominator is opposite in sign for the plus. All right? Do not, unless you're just really good at memorization and you want to, do not memorize this. You don't need to. All right? We're going to do a couple of examples here and then call this good. So if I have cosine, here's example 2. I'm going to write as a trig function of theta. Of theta. Cosine of 180 degrees minus theta. So I'm going to look back up here. I know this is a minus, so that means my formula is going to be plus. So I have cosine of my first term, which is 180, and cosine of the second term, which is theta. Because this is a minus sign, I'm going to add between them. And then I have sine of the first term, which is 180, and then sine of the second, which is theta. And then you simplify that. If I'm looking here, I know cosine of 180, if you're looking at your unit circle, I'm telling you the unit circle is a big deal, right? A big, big deal. Cosine of 180 is over here, so I know my point is negative 1, 0. This is 180. So I end up with negative 1 times cosine theta. The sine, which is my y value, ends up being 0 times the sine of theta. So I end up with negative cosine theta. That's it. That's it. You literally plug into a formula. That's all that's happening here. Let's do like 2 more. We'll do one more. We'll do one sine and we'll do one tangent, and then that's it. So here's example 4a. I have sine of 30 degrees plus theta. All right, so this is a sine of a plus, so I know it's plus to plus, and they're sine, cosine, cosine, sine. So then this is actually going to end up being sine of my first times cosine of the second plus, because it's the same, cosine of the first times the sine of the second. The sine of 30 degrees, go back to your unit circle. Your 30 degrees here is this pi over 6. So if I'm looking at this, I know that this is 30 degrees. My head is telling me that this, my y hits it at halfway. So I know that this is the 1/2 and this is the square root of 3 over 2. That's how my head does every time. So my sine here is going to be 1/2 cosine theta plus the square root of 3 over 2 sine theta. And there's nothing you can do to simplify that. It is exactly what it is, and that is your final answer. There's no like terms because they both have a value. That's it. Literally that easy, guys. Yeah, we're not getting crazy on this, not even a little bit. Let's change colors because I feel like we're swamped in blue. Here, let's do example 4b. Let's put a minus sign in there. Tangent of 45 minus theta. So now tangent, and I'm doing minus, which means it's the same on top, then opposite on the bottom. So I get the tangent of the first one, which is 45, minus, because it's the same sign, tangent of theta over 1 plus, oh man, I put AB up here. Sorry, guys. Doggone it. This is tangent A, tangent B. Sorry. Note that. Tune that in. Like I may have said it and I just didn't write it. You guys could have been hollering at me the whole time. Sorry. So here I have tangent of my first, which is 45, and tangent theta. Hopefully that cleared it up if some of you were like, what? Where? What? Now I'm going to scoot this up so we can see it better. So the tangent of 45 degrees over here, we know is this 45 degrees. Well, this is 1 over the square root of 2 and 1 over the square root of 2, or square root of 2 over 2, any of that. But tangent is the same thing, so sine over cosine. If you have the same thing, tangent of 45 here is 1, because it's the exact same thing on the top and the bottom. So I have 1 minus my tangent of theta over 1 plus, I know this tangent of 45 here, this goes to 1, this goes to 1, so I just have 1 plus tangent theta. Now here's my question to you. Can I cancel out these tangents? Absolutely not, because this is touching a plus or minus sign. Both of them are. The only time you can ever cancel anything out with a rational expression is if it's multiplied. All right? That's it, guys. This is the whole section of